All right, so just to hit some of this vocabulary really quick, segment LE is from, if you connect L to E, so it's a segment, so it's a line. So notice that goes from one edge of the circle to the other, and it goes through the center. So that is called a diameter. So that's our diameter. All right, in segment FE, if I get rid of my highlighting here, and I highlight F to E, that is from here, the center, to the edge. So anytime you go from the center to the edge, remember that's a radius. And then line EJ, so from E, which is there, to J, that's all the way outside. Remember when a line goes outside the circle and passes through the circle twice, or touches it twice, that is a secant. Now it looks like we're talking about angles, so let me erase some of this. So now we're looking at angle EFG, so you must go in that order, E to F to G. Notice the vertex is at the center, so that's a central angle. Use an angle mark there. And then we have EHG, so if I start at E, go to H, remember order matters, then to G, notice the vertex is on the circle, so it's on the edge of the circle. So remember that's an inscribed, inscribed angle. Now segment HG, so from H, which is here, to G, which is here, so I'm going to make this bold because I'm writing all over it. So notice it connects 2 points that are on the circle's edge, so that's a chord. So anytime it connects 2 points on the circle, that is a chord. All right, now we're looking at line KM, so from K, which is here, to M, and it says a line that lets you know it keeps going. So notice that grazes the circle. It does not go inside, it just grazes it at one point. So anytime it grazes the circle, that is our tangent. Now segment EF. Segment EF is from here to here. So that is another radius. Alright, because it goes from the center to the edge. So remember, anytime it goes from the center to the edge, that's a radius. So next we have segment EH. So from E to H, that starts at the edge of a circle, goes to an edge of the circle. Doesn't pass through the center, so it's not like a diameter or anything. It just connects 2 points on the circle. So that again is a chord. Then we have segment FG. So from F, which looks like is here, to G is here. That actually is a repeat question because it was number 2 as well. So that is another radius. Remember, radius is always through the center, or from the center to the circle's edge. So that's radius. So then we have line MJ. So if we highlight M to J, that's here, but notice that it's a line, so it continues on and it just grazes the circle at point M, so that is a tangent. Again, it's just another way to name that same tangent. So now we're moving on to arcs. So notice if it's an arc, that means you're going around the circle from one point to another. So arc M to J. So starting at M, going around the circle to, not MJ, MH, excuse me, MH. So from M to H, that right there is an arc. And remember, you have a few different options for arcs. You have minor arc, major arc, semicircle. So that, because it's less than a semicircle, anytime it's less than 180, that is a minor arc. Then we have arc EML. Remember, you have to go in that order. Anytime it's named with 3 letters, I already know it's going to be a major arc, but I have to make sure it's not a semicircle. So from E to M, then to L. So notice that EML, that creates a semicircle. That's half of the circle, so that's a semicircle. And then next we have arc EMG. So once again, I know it's 3 letters, so it's going to be a major arc. E to M to G. I just want to make sure it's not a semicircle. So EMG is definitely a major arc. And then the last one is, let me erase this here, arc EG. So if I connect E to G, notice that that is less than half the circle. So that again is a minor arc. So that's all the vocab. Make sure you're familiar with each thing and what they are. So now let's move on to using some of the arc-angle relationships. So the first thing it asks us for is a measure of arc BC. So remember, an arc, you're going on the circle's edge, so from B to C. So we're looking for this amount. So remember that they're giving you something for a reason. They're giving you this angle right here. So this angle, if you notice this angle, remember angle has like a V. This angle has a vertex here that is at the center. Remember, the relationship with the center is that it's the same as the arc that it opens up to. So that arc is also 132 degrees. So the next thing I want you to find is the measure of angle BAC. So you have to follow in that order, B to A to C. Ooh. All right, B to A to C. So notice the A is in the middle, so that's where your vertex is. So there's our vertex. It's the pointy part of the angle. I'm just tracing it out. So that angle is on the circle. Remember, the relationship to find the angle is you divide the arc by 2 to get the angle. So we have to find the arc. Well, our arc that goes with this angle is also that same arc. So we have to divide that arc, which is 132, by 2 to get the actual angle back there, which is 66, I think. Yep, so that angle is 66 degrees. All right, so make sure you remember the relationship for a central angle at the center. The vertex is at the center. It's the same as the arc. And then the second relationship here that was used is that if the vertex is on the circle, then that's half. The angle is half of the arc. So you use that same arc, but used it 2 different ways. All right, so for the next one, the measure of EG. So if I connect E to G, this is what I need. I need to find all that. Now, they gave us that we have a 90-degree angle here. So remember, the angle is the same as the arc. They also gave us that we have a 5-degree angle here, so that's the same as the arc, because, and the reason why I'm saying they're the same is because they're all at the center A. Remember, central angles are the same as the arc. So we have that much. Now we need to figure out this whole blue section, and we have a piece of it. We have that 5-degree right here, but we also need to find this. So in order to find that, if you look at the marks that they're giving us here, they're giving us this congruent mark with this one. So we know that these 2 pieces have to be the same, whatever they are. They have to be the same. So what we could do is we can find a diameter, because remember, diameters are your friend. So I see a diameter right here. All right, I could use that because that diameter creates a semicircle, which is 180 degrees. So this is 180. Should probably use a different color for that. Let's see. Let's use green. All right, so this semicircle is 180 degrees. And we know that this part from here to here is 90. And we know that these 2 pieces right here, this one and this one, have to be congruent because of these marks. So basically, if we do 180 minus the 90 that's already there, that gives us 90 that these 2 pieces have to share. So those 2 pieces have to share, but since we know they're equal pieces, we just divide the 90 by 2, and that gives us that each of those pieces have to be 45 degrees. So each arc right there is 45 degrees. So this is 45 degrees, and so is this arc here, 45 degrees. So now if I focus back on what I'm actually finding, which is EG, so from E to G, I add up everything along that arc. Well, I'm adding the 45 degrees and the 5 degrees. So that is 50 degrees. So you kind of got to remember to find the diameters. If you find a diameter, you can use a semicircle. And once you find a semicircle, then you could see how many pieces are on that semicircle and figure out, what arcs you can find from that. All right, so moving right along to number 19. This one, they give you that you have 90 degrees, but they just give it to you in the notation. So you know that the arc is 90 since we're at a center. That angle here is at the center. This angle here is 20, so we know the arc is also 20. And we can use the diameter because I see a diameter right here. So if I just use my diameter, I know that this entire semicircle has to add up to 180. Well, right now I have 90 of that, and I have 20 of that. So to find out this other part right here, I just have to add up what I have so far, which is 110, and then I have to take that amount and subtract it from 180 to figure out what must be left over. So if you subtract, you get that missing arc, which will complete the semicircle right here, is 70 degrees. Now I'm just finding stuff because I can. Now it's ultimately asking us for angle EBF, so from E to B to F. Now we're looking for that angle. Look at the center. The center is at the center. Remember, the relationship for the central angle is that it's the same as the arc it opens up to. So if this arc is 70, the angle itself is also 70 degrees. So our answer is 70. All right. Next. So for this one, the key here is to notice that you have vertical angles at the center. So you have vertical angles because together these two diameters, don't like the way that looks, let me start over. Those two diameters cross and make an X. So remember, anytime you have an X, you have vertical angles. Vertical angles from unit 2, vertical angles are congruent. So we know that these two angles that they're pointing to are congruent. Remember, whenever two things are congruent, you set them equal to each other. Oops, that is not a 2. That should be a 5. All right, so that is finding, once we solve that, let me just go ahead and solve it really quick. Subtract 2x from both sides. Here's our equal sign. And we get that is 2x minus 5 equal to 65. And then if we add 5 to both sides, we get that 2x is equal to 70. So if we divide by 2, x is going to equal 35. That is x. You are not done because if you pay attention, you are looking for the measure of angle CPA. So if you highlight C to P to A, that's that angle, which this expression is in there, but now we know x is 35. So we're going to substitute that in for x, and now 4 times 35, that's 140. So this is 140 minus 5 equals 135. So our final answer for the measure of angle CPA, equals 135 degrees. Like I said, if this is multiple choice, I say it a million times in class. If it's multiple choice and you just feel like, oh, I found an answer, and you don't look at what you're originally supposed to be finding, you may circle x equals 35 as an answer because it's going to be sitting over there in the multiple choice for anyone who stopped short. So make sure you check to make sure you answer the question. All right, number 21 has a lot going on, but you have to figure out what you want and what we're looking for and what you need to find it. So what I mean by that is we're looking for this question mark. This question mark is an angle. This is the vertex of that angle. The angle expands. You could expand the angle out so you can see what arc it goes to. So if I just draw out the sides, you see that this angle opens to this arc. So in order to find that angle, you need to find that arc. All right, so to do that, you kind of have to see what you're given. You're only given that this angle here is 62. So if I kind of stretch that out, that angle is opening to this arc. So if you remember the relationship, if it's on the circle, the vertex right there is on the circle. So if it's on, to get the arc, you multiply the angle by 2. So multiply the angle by 2 to get the arc. Get the arc. So if you do 62 times 2, That gives us 124. So our arc is 124 degrees. Yeah, it's not the arc we want. Ultimately, we want that arc, but at the same time, that's going to help us get there, because if you notice, this line right here is a diameter. And remember, diameters are your friends. So this entire side has to add up to 180 degrees. So now I can do 180 minus the 124, and that'll give me what's left over, which has to be our green arc right here, because that's the rest of the semicircle we don't know. So that is 56. So now we know our arc is equal to 56. And now our green angle here that's kind of written over now, that we're actually looking for, that angle, now that we have the arc, we have to divide the arc by 2 to get the angle. So 56 divided by 2 will be our answer for the angle, which is 28 degrees. So the measure for the angle that we're missing, the question mark angle, is 28 degrees. All right, so it's a lot, but maybe you need to rewind all that. But we used the inscribed angle where the vertex is on the circle. We used it twice, once defined in arc, and then we used the relationship for a semicircle. We subtracted from 180 to get the missing piece of arc over here in green, and then we divided by 2 to get the angle. Now that goes with. So next with number 22, once again, diameters are your friends. If you notice, you have a diameter right here. A diameter splits the circle in half, which we know that this has to be 180 degrees. Well, we already have that this right here is 180. So to figure out what this little piece has to be, we're just going to do 180 minus the 150 that's already there, and we get 30 degrees. Now that's not our final answer, but guaranteed if this is multiple choice, they're going to have that as an option for anyone who just grabs it. That arc opens up, or goes with that angle there. And that angle is the angle we're looking for, ABC. So if you follow in order, A to B to C, oop, that's ugly, let's do that again. A to B to C, you'll notice it is that angle right there we're looking for. So if the vertex is on the edge of the circle, then you remember to get the angle, you just do the arc divided by 2. So you do 30 divided by 2, and that gives you that the angle is 15 degrees. So the measure of angle ABC equals 15 degrees. So for this next one, basically we need to see that it's pointing to this angle right here. So this angle opens up to
Hillgrove.
Don't even. You better get that out of here. Do y'all hear this nonsense? I can't even do it. I can't even do it. Let me just pause this so I can abuse my husband. Okay, I'm back. Hopefully he learned his lesson. So, yeah. So that opens up to this arc right here. And if you notice, the other angle it's pointing to is this angle here. So that angle, if I trace it, notice it also opens up to that same arc. So two angles that open up to the same arc where the vertex are both on the circle. So you have two inscribed angles that open to the same arc. No matter which one you're looking at, they're going to be congruent. So we know that the 3x has to equal the same thing as the 2x plus 13. And now we can just solve for x. So if we subtract 2x from both sides, we have 3x minus 2x is 1x. And then that's equal to, cross that out, got it equal to 13. So we're asked to do is find the value of x. So at that point, we are done because we have x is equal to 13. All right, so now we find the value of y in number 24. So remember that anytime you have a quadrilateral inscribed inside of a circle, so basically this four-sided shape, all the vertices are touching the edge of the circle, so that's why it's called inscribed. Opposite angles are supplementary. They add up to 180 degrees. So angle B and angle D are opposite angles because they're across from each other. They add up to 180 degrees because they're supplementary. So that means that they need to add up, 3y plus 4 needs to add up with the 2y plus 16 to equal 180 degrees. So now if you just combine like terms, well, we're going to add the y's together first. So positive 3 and a positive 2 is 5y. And then I'll add my constants, positive 4 and positive 16. So that gives me positive 20. And I'm just going to bring down my equals 180 degrees. So now if I solve it and subtract 20 from both sides, I have that 5y is equal to 160. And then if I divide both sides by 5, I have that y is equal to 32. And notice all they wanted us to do was find y. They didn't say like find the measure of angle B, because then we'd have to plug y back in. All we had to do is find y, so we're done at that point. All right, so next, number 25. Key here is noticing that PQ and QR together form a semicircle since we have a diameter here. And you should know that a semicircle is 180 degrees because it's half a circle. So that means that this plus this has to add up to 180 degrees. So similar to the last problem, you have to show two things add up to 180 degrees. And then we solve it just like the last problem. So I combine like terms and I have 10x and a positive 1 and a negative 1 actually just equals 0 because they invert each other. So that equals 180. And then we're down to one step, which is to divide by 10. So we get that x is equal to 18. All right, they only asked us to find the value of x, so I'm done at that point. So now moving on to number 26. I noticed that my vertex for the angle that is there is on the outside. So remember the relationship for outside is that the angle is equal to the big arc minus the small arc divided by 2. So key here is to put everything in the right place. If you look at the angle in the image is x. So x should come before the equal sign. Now big arc, well, if you look at this, we do have two arcs. Doesn't look like we do because some people are like, well, there's only one number, who cares? You still have an arc right here. And then you have another arc right here. So hopefully you could tell which one the bigger one is. The bigger one is definitely the 243, excuse me. We're subtracting the smaller arc. Yeah, the purple one that's there, there's no number on it, but you can find it because an entire circle adds up to 360. So you could subtract the 243 that's already there, and that'll give you the rest of it. So that's 117. All right, and then so that's our small arc now, so 117. And now remember to divide by 2. So there's no solving to do since x is already by itself. So you just put this in the calculator, see what you get. So 243 minus, excuse my husband, he obviously is sick, minus 117 divided by 2. He's down there coughing. So x equals 63. And that is an angle measure because x is an angle, so we are done. We found x. So you got to remember the formula and remember to put stuff in the right place. So in the next problem, notice the vertex again is on the outside. And if it's on the outside, we're still going to use the angle equals big arc minus small arc divided by 2. And so if you look inside, the angle measure is x. And if you extend out the angle, that tells you what arcs you have to use. You have to use the arcs that are inside of the angle. That's those two. If they put a number here or a number here, you can't use those. It has to be the arcs that are inside of the angle. All right, so we have x equals, our big arc there is 108 minus our small arc, which is 34 divided by 2. Once again, you just do the math here because x is already by itself. So we do 108 minus 34. And then we divide by 2. And we get 37. X equals 37 degrees. All right. So moving right along to number 28. So this situation, you notice the angle that they have an x in, this angle here, it's on the inside of the circle, but it's not necessarily at the center of the circle. So the inside formula is that the angle equals the big arc plus the small arc divided by 2. So remember that it has to be the arc that the angle opens up to and the vertical angle, which would be here, would open up to. So it has to be those two arcs that are used. If they gave you one at the bottom, like a number here, you couldn't use that number. That number would go with that angle. So you got to make sure you're using the right arcs, because sometimes you may have to find something else before you can use the actual relationship. But we are using 53 and 41 in this problem. So the angle in this case has an x in it, so I'm going to put an x in the angle spot. The big arc is 53 plus the small arc is 41 divided by 2. And x is by itself, so I'm just going to do this math really quick. Let me just do it by hand. So we have 94 divided by 2, which is 47. So x equals 47 degrees since it's in an angle. And that's all we had to find was x. The next one's very similar. If you notice that the angle that you have, that is also on the inside of the circle. The vertex is on the inside. It's all about the vertex. The vertex is on the inside, not necessarily at the center. So it's the same formula as before. So we're doing the angle equals the big arc plus the small arc divided by 2. So that angle opens up to that arc. So that's an arc we have to use. And the vertical angle opens up to that arc. So now this one's about putting things in the right place. If you look at what's in the angle spot, well, what's in the angle spot is the 121. So that has to go in the angle spot in the formula. Equal to, well, look what's on the big arc is 203 plus whatever's on the small arc, which is our question mark. So I'm going to use a variable. I'll just use x since it's most commonly used. And then we're going to divide by 2. So this one you do need to get x by itself. Remember that the inverse of dividing by 2 is to get rid of it by multiplying both sides by 2. So those 2's cross out, and then you could do 2 times 121. So we get 242 is equal to 203 plus x. So now your last step is to subtract 203 from both sides. And we get that x is equal to 39, and that is an arc measure, so that is a degree, and we just found the measure of the arc. So for the next one, they have the 8x plus 5. It is in this angle, so that angle opens up to that arc, and the angle that's vertical to it opens up to that arc. So using this expression, we have to use this arc here and this arc here, and that's what we have stuff on, so it's fine. But notice, once again, the vertex for the angle we're using is inside the circle. So inside is angle equals big arc plus small arc divided by 2. So whatever's in the angle is what you have to put first on the left side of the equal sign. So that, in this case, it's 8x plus 15. Equal sign, then the big arc is going to go at the top of the fraction first, which is 15x minus 10, and then plus the small arc, which is 50 divided by 2. So if you wanted to now, you can go ahead and multiply by 2 on each side. There's a few different ways to do this one from the jump. But remember, when you multiply by 2, you're distributing the 2 to both things on the left because there's more than one term over there. On the right, those are going to cross out there because they're inverse operations. So now when you distribute, you have 2 times 8x, which is 16x, 2 times 15, which is positive 30, that's a 0, equal to, I'm just going to bring down everything that I have up there. You could have combined like terms up there from the jump, but I'm just going to go ahead and do it now. So just like I said, there's multiple ways to start it off. These two are on the same side, and I can just combine them. So I'm going to rewrite what I have on the left, and then I'm going to combine that negative 10 with the 50, and that's positive 40. So now I can go ahead and get my x's together. So I'm going to subtract 15x from both sides, and that is going to give me that 1x, which is just x, plus 30 is equal to 40. And then since there's no coefficient in front of x besides 1, I can go ahead and subtract, and I'll have my answer. So x is going to equal, I'm running out of room, but x equals 10. Now be careful, they asked to find RS. So this is a case where you actually have to take that 10 and plug it back in for RS. So we need this arc here. So make sure you look to see that what the directions say. So I'm going to do 15, and then in parentheses substitute in my x, which is 10, minus 10. So 15 times 10, well, that's 150. Kind of working up here because I'm running out of space. Minus 10. 150 minus 10 is 140 degrees. So my final answer is 140 degrees for the measure of arc RS. Alright, so notice in these, the relationships are different because we're not looking for angles and arcs. We're using segment pieces or pieces of segments or chords or secants, whatever it may be. This length is 3, this length is 4. This length is x, this length is 6. So we're not dealing with angles and arcs, we're doing with lengths. So the formula for for finding the lengths in two chords is that basically you multiply the pieces on the same line. So I'm going to do 3 times 4 equal to this piece times this piece. So 6 times x, which is just 6x. So there we have 12 equals 6x. And then if we divide both sides by 6, we get that x is equal to 2. That's x. Notice that's all it wanted us to find, so we are done at that point. This one, no matter what's on the lines, if it's two chords with a cross inside of a circle, just like these, you're going to multiply the expressions that are on the same chord. So I'm going to do 6 times the quantity of x plus 4. Make sure you put parentheses if it's more than one term. And then for this one, this chord here, I'm going to do 12 times x, which is just 12x. So now if I distribute, I'm going to get 6x plus 24 equal to 12x. And then I'm going to subtract 6x from both sides, and that'll give me that 24 is equal to 6x. And then if I divide both sides by 6, I get x is equal to 4. Now, just looking up, it did only want us to find x, so I'm done at that point. Notice 33 is different. We have a angle that's all the way on the outside. Once again, we're finding segment length. So you got to remember this is 6, this is 4, this is 5, this is x. This is different though. It's not just, each piece times each other. You're not just multiplying 6 times 4 here. So what you have to do is you have to write an expression to represent the entire length. And then we're going to do the outside piece, which is 6, times the entire length. Well, that's just 6 plus 4. So in order to get an entire length, you're adding. Just keep that in mind. You're adding. So that's really just 10. So I'm doing 6 times 6 plus 4, which we know is just 10, but I'll put that in there in a minute. And then on the other one, we're doing 5 times the whole expression for that length, which is 5 plus x. Remember, you're adding when you're doing the whole expression. So we're doing on that side the outside piece times the whole length, which is 5 plus x. So anytime it goes outside the circle, you're doing the outside piece times the expression for the whole piece. So that's the part where you have to figure out the expression for the whole piece. Now you just do any math. I want to combine these first, so I'm going to do 6 times 10 instead. I can't combine 5 and x because those aren't like terms, so what I'm going to do instead is I'm going to distribute. So 5 times 5 is 25. 5 times x is 5x. So now I know this side is 60 equal to 25 plus 5x. And now I'm going to subtract 25 from both sides. And now I have that, what's that, 35 equals 5x. And then if I divide both sides by 5, I get that x is equal to 7. And that's all it wanted me to find was x, so at that point I'm done. So notice the difference in the two situations here. In number 31 and 32, I can basically summarize what the relationship is. Let me use a different color though. Let's use green. So the relationship in this case, I just call it piece times piece, because I multiplied the two pieces along the same line, equal to, erase this, equal to the other piece on the other line, or piece times the other piece. That's just kind of how I summarize the relationship, because I did the other piece times the other piece. Now in 33, it's a lot different, because in this case, I did the outside piece, which was 6. So I did the outside, the part that was outside of the circle on one of the secants, times the whole length. And I set that equal to the other outside piece, which was 5. So I call this outside times whole. I'm running out of room, but times the whole length. And I just kind of like reminding myself to add, so I put like a little plus sign above the whole, because I know I need to add to get the whole. So I did the whole length. So anytime it's a secant where it goes outside the circle, you want to do outside times whole. All right, so next, here's another example where we have a secant right here. So we're going to do the outside piece, which is 9, times the whole length, which we could express as 9 plus 7. All right, now the problem is, if you get stuck on the outside times whole, is this doesn't go inside. I don't like that I'm using that color, this color. We'll use this one. This doesn't go inside. That's a tangent piece. So anytime it's a tangent piece, you don't do outside times whole, because there's no, it doesn't go inside the circle. So any tangent piece, you square it. So this relationship is that you do your tangent piece squared and then your outside times your whole for the secant piece, or the secant. So now we have on our tangent, we have x squared equal to, and then our secant, we have 9, which is our outside piece, the part that's poking out the circle, times the expression we used for the entire length, which is 9 plus 7. And so if we simplify, we get x squared equals 9 times 16. And 9 times 16 is 144. And so if we take the square root of both sides to get rid of the squared, you got to take the square root, so those cross out. So you're just left with x is equal to 12. Since we're dealing with the lengths, you don't want to use negative 12, so we're just using the positive. So x equals 12. All right, so we're done at that point. So the key here is to know that anytime you have a tangent piece, you just square it. And then anytime you have the secant, you do the same thing as the last problem. You do outside times the whole expression. Now, notice in number 35, you have two tangents. You have a tangent here and a tangent here. Both of those tangents are coming from the same point. So anytime you have two tangents, those two tangents are equal because they're coming from the same point to the circle. So all we do is we set those equal to each other. And we just solve it like normal. So I'm going to get my variable terms together first, and that's going to give us that 3x minus 4 is equal to 2. And now if I just solve my two-step equation here, let's see, I should not be adding 2. That is not good. Don't ever do that. Don't leave a side empty. We need to be adding the 4 to both sides. I'm trying to rush so this video isn't like 2 years long. Alright, so then we have 3x is equal to 6. And then if we divide both sides by 3, we get that x is equal to 2. Alright, so that's x. Notice they did not just say find x, they said find JM. You must catch that. I always catch it by once I finalize an answer, I think I'm done, I always look back up to see did I really answer the question. So right there I notice, well, didn't quite answer it, but I'm almost there. So I have to find JM, which JM is from here to here. So I got to put x is equal to 2 in for x there. So we got the 2 on the outside, the 2 for x, plus the 2. Lots of 2's. So 2 times 2 is 4, plus this other 2, which is 6. Now technically, since both of these two tangents are supposed to equal each other, I could check it and make sure it really makes sense because both tangents should be equal length. So if I wanted to, I could put a 2 right there and do 5 times 2, which is 10. 10 minus 4 is 6. So my math is correct because both tangents do work out to be the same number. So the answer for JM, to give the answer to to the actual question, JM is equal to 6. Remember, it's not in degrees. These are talking about lengths. All right, so number 36, which is our last one. This, we've done very few problems like this, but anytime it's showing you the distance from the center to a chord or a secant or something like that, it's showing you that this distance and this distance are the same. So anytime that you have this as a right angle, it's showing you that that is like the distance to the chord. So if the chords themselves are the same length, these both are 12, then the distances to the chords are the same length. Well, another word for same is equal. So 3x has to equal 7x minus 8. So that's anytime the chords are the same length, then the distances will be the same length. So you can set them equal to each other. So now here, you don't want to subtract 3x even though it's smaller, because then this will leave the side empty. You don't want to have an empty side. So you want to go ahead and subtract the 7x, even though it's going to become negative. You'll deal with it in a second. So that's going to be negative 4x equals negative. Notice that's a negative 8 there when you bring it down. So now when you divide by negative 4 on both sides, you're going to get that x is equal to a negative divided by negative. That's a 2, positive 2. And that's our x. I'm thinking I'm finalizing, but instead I'm going to look up here and make sure I should be. And I shouldn't be, because FE is what we're looking for, which is from here, the center, to here. We're looking for this. So now that we found x is 2, I'm going to put 2 right there in the parentheses, so that's going to be 3 times 2, which is actually 6 too. So that's 6 as well. So the answer for 36 is also 6. All right, hopefully you guys are studying. Hopefully you're making your note card if you're using one. But yeah, get it going. Rewind if you have to. Good luck.